Hello everyone. In this first tutorial of the series on fire and smoke with a fluid simulator in Blender 4.5, we'll see the two fundamental elements required to create a simulation in Blender. As mentioned in the introductory video of this series, the PDF version of this and other episodes is available for free download at the link you'll find in the description. Let's start with an empty Blender scene. To add fire or smoke to the scene, you might think the first step is to insert an object that emits these elements. That assumption is correct, but it represents only half of the fundamental components needed to run a simulation in Blender. Still, let's begin by adding to the scene the object that will act as the emitter. Blender's fire and smoke simulation tools are located in the Physics tab of each object. The type of component we need to add is Fluid, which handles both liquid and fire or smoke simulations. At first, you'll only see a menu called Type, which doesn't yet distinguish between fluids or other categories, but simply lists the possible actor roles in the simulation. The tooltips of the various element types already give us some hints about their functions. In particular, we can see that the flow type is used to add or remove elements from the scene. Since we created the first object to make it an emitter of fire and smoke, we'll choose this type. Several new options now appear in the Components panel. The first one is Flow type, which by default is set to smoke. Opening the menu, we notice that Liquid has only one option, while Fire and Smoke offer three possible choices, the two elements separately or their combination. The Fire and Smoke option contains parameters and settings for both, so for the initial part of this tutorial series, I'll select this one. If you're familiar with other types of physics simulations in Blender, such as cloth or collision, you might expect that at this point, it would be enough to go to the first frame of the timeline and press the play button to start the fire and smoke simulation. However, doing this produces no result. So let's go back to the first frame of the timeline and introduce the second fundamental actor required for a fluid simulation, the domain. Every fluid simulation must take place within a 3D space, also called a volume, defined by a mesh. In Blender, this volume is called the domain of the simulation. This is necessary mainly for performance reasons, since these simulations require a lot of memory and computation, as we'll see. The domain can be any shaped object, but Blender will ultimately take its bounding box. For this reason, the most obvious choice is a cube, scaled appropriately. After enclosing the emitter object inside the cube that will serve as the domain, let's select the cube and add a fluid component of type domain, with the subtype set to gas. The cube will immediately turn transparent, revealing its structure. You'll also notice a smaller cube appearing in one of the lower corners, and we'll soon see what that's about. The most significant change, however, is that the inflow object inside the domain is now surrounded by flames. With the first frame of the animation set as the current frame in the timeline, click play to start the simulation. Something definitely happens, but as a first fire and smoke simulation, it seems rather disappointing, since the fire only appears in the first few frames and then only the smoke remains. The reason for this behavior lies in one of the emitter object settings, so let's select it. The fluid component parameter we're interested in is flow behavior, which by default is set to geometry. The tooltip tells us that geometry uses the current geometry to produce fire, while the inflow mode continuously adds fire to the scene. So let's switch the mode to inflow, go back to the first frame of the timeline, and click play again. The expression adds fire for the inflow is the key to everything, because inflow objects continuously generate new simulation elements at each frame, starting from the geometry. The geometry mode, on the other hand, considers the geometry only at the first frame, immediately consuming it, so to speak. In a way, using the geometry mode is like burning a small piece of paper or having a smoke machine emit a single puff, while inflow is like a stove burner or a smoke machine that keeps producing smoke continuously. You may have noticed that the flames, especially at the bottom of the object, look a bit too blocky, or rather cubical since we're in 3D. The reason for this appearance lies in a domain parameter called resolution, which determines how the domain's volume is subdivided into small cubes. This resolution is visually represented by the little cube that appears in a lower corner of the domain. In fact, especially with low resolution values, you can clearly see how flames and smoke are divided into cubes of that size. Fluid simulations work by subdividing the domain's volume into small cubes called voxels. These are the smallest units used to calculate the simulation, so a voxel is the 3D equivalent of a pixel in 2D images. As with pixels, a higher number of voxels for a given volume results in better quality, but at the cost of more computational power and disk memory. The best approach is to start with a default resolution value of 32, then adjust the other parameters until you achieve the desired shape for the fire and smoke. After that, increase the resolution to test further, and finally raise it to a very high value for the final result. Speaking of memory usage, let's see where fluid simulation data is stored, especially since I haven't yet saved the project file. This information is found in the cache section of the domain object, and from the path shown there, we can see that Blender has created a folder on disk to store the simulation files. Since I haven't saved the current project file, this folder is created in a temporary location. So remember not to do what I did. Always save your Blender project file before creating the domain and other fluid simulation elements. That way, the cache folder will be created in the same directory as your project file, and you won't have to go searching for it on your disk. If at this point we switch the viewport shading mode or run a render at an intermediate frame of the timeline, we won't see either fire or smoke. That's because what we currently see in the 3D viewport in solid mode is just the voxel visualization of fire and smoke in 3D space, but we haven't yet defined their materials for rendering. We'll cover this in the next episode. That's it for this tutorial. If you enjoy my content, the best way to support me is to subscribe to the channel and leave a like on the video. Thank you. See you soon.